Welcome to your ultimate guide for cracking Android interviews with confidence. Whether you're a beginner or an experienced developer, this video will walk you through the most essential concepts, real interview questions, and practical explanations. We'll cover everything from Android core principles to advanced architecture, Kotlin features, Jetpack Compose, security, testing, and even scenario-based problem solving. By the end, you'll have a solid foundation to tackle interviews at top tech companies. Let's start our journey to mastering Android interviews together. Let's begin with the building blocks of Android development. Every Android app is made up of components like activities, fragments, services, broadcast receivers, and content providers. These work together to handle user interfaces, background tasks, and data sharing. Understanding how these components interact is crucial for both app design and interview success. We'll also touch on views, layouts, and the manifest file, which acts as the blueprint for your app. Mastering these basics sets the stage for deeper topics ahead. Activities and fragments are often compared in interviews. An activity represents a single screen with a user interface, while a fragment is a modular section of an activity. Fragments are reusable and help create responsive layouts, especially for tablets. Knowing when to use each is key. Activities are entry points, while fragments allow for flexible UI design within those screens. This distinction is frequently tested in interviews, so be sure you can explain and implement both. Context is a core concept in Android. It refers to the current state of the application or object. There are different types: application context and activity context. Application context is tied to the lifecycle of the app, while activity context is tied to the lifecycle of an activity. Using the wrong context can lead to memory leaks or unexpected behavior. Interviewers often ask about context usage, so be ready to explain the differences and best practices. Intents are messaging objects used to request actions from other app components. There are two types: explicit intents, which launch a specific component, and implicit intents, which let the system find the right component based on intent filters. Intents enable communication between activities, services, and even different apps. Understanding how to use and configure intents is fundamental for Android development and a common interview topic. The Android Application Lifecycle describes the process your app goes through from launch to termination. Key methods include onCreate, onTerminate, onLowMemory, and onTrimMemory. Each plays a role in managing resources and app state. Understanding the lifecycle helps you write efficient, bug-free code and is a frequent interview question. Be prepared to discuss how you handle initialization, cleanup, and memory management in your apps. In Android, the UI thread handles all user interface operations, while background threads are used for long-running tasks. Mixing up these threads can cause your app to freeze or crash. Understanding the difference between the UI thread and background threads and knowing when to use each is vital for smooth app performance. Interviewers often test your knowledge of threading and concurrency in Android. Handlers, loopers, and MessageQueues are tools for managing threads and messages in Android. A handler allows you to send and process messages and runnable objects associated with a thread's message queue. The looper keeps the thread alive, processing messages as they arrive. This system is essential for background processing and updating the UI from other threads. Mastering these concepts will help you answer advanced threading questions in interviews. Android provides several options for data storage: SharedPreferences for key-value pairs, SQLite for structured data, and RoomDB as an abstraction over SQLite. Each has its use case: SharedPreferences for simple settings, SQLite and Room for complex data. Interviewers may ask you to compare these options or implement data storage in a sample app. Be ready to discuss their advantages and limitations. When passing data between activities or fragments, you often need to serialize objects. Android offers Parcelable and Serializable for this purpose. Parcelable is faster and optimized for Android, while Serializable is simpler but slower. Interviewers may ask you to implement Parcelable or explain the differences. Knowing when and why to use each can set you apart in interviews. Effective debugging is a must-have skill. Android provides tools like Logcat for logging and the Profiler for performance analysis. Logcat helps you trace errors and monitor app behavior, while the Profiler gives insights into CPU, memory, and network usage. Being comfortable with these tools shows interviewers that you can identify and fix issues efficiently. Work Manager is Android's recommended solution for background tasks that need guaranteed execution. It supports scheduling work with constraints, like running only on Wi-Fi or when charging. You can use periodic work requests for tasks that repeat at intervals. Interviewers may ask you to design background sync or periodic tasks, so understanding Work Manager is essential. Object-oriented programming, OOP, is the foundation of Android development. A class is a blueprint for creating objects, defining their properties and behaviors. An object is an instance of a class, occupying memory and performing actions. Interviewers often ask you to explain these concepts or design simple classes during interviews. Kotlin supports both primary and secondary constructors. The primary constructor is defined in the class header and is used for initializing properties. Secondary constructors provide alternative ways to create objects and must delegate to the primary constructor. This flexibility is useful for different initialization scenarios. Interviewers may ask you to demonstrate or explain constructor usage. Inheritance allows one class to inherit properties and behaviors from another, promoting code reuse and hierarchy. Polymorphism enables objects to take many forms, allowing for flexible and dynamic code. In Android, you often extend classes like activity or view. Interviewers may ask for examples or have you implement inheritance and polymorphism in code. Abstraction hides complex implementation details and exposes only the necessary parts. Abstract classes and interfaces are tools for achieving abstraction in Android. Interfaces also enable multiple inheritance, letting classes implement multiple behaviors. Interviewers may ask you to design interfaces or explain their advantages in large projects. Encapsulation is about bundling data and methods that operate on that data within a class, and restricting access using access modifiers like private, protected, and public. This keeps your code secure and maintainable. Interviewers may test your understanding by asking you to design encapsulated classes. Kotlin's null safety features help prevent null pointer exceptions. By default, types are non-nullable. You can use nullable types, safe calls, the Elvis operator, and not null assertions to handle nulls safely. Interviewers often ask you to explain or demonstrate null safety in Kotlin. Kotlin allows you to add new functions to existing classes using extension functions, and to write concise code with lambda expressions. These features make your code more expressive and flexible. Interviewers may ask you to write or explain extension and lambda functions. Data classes are designed for storing data and automatically generate useful methods like toString and equals. Sealed classes restrict class hierarchies, making them ideal for representing restricted states. Interviewers may ask you to use or compare these special classes. Coroutines are Kotlin's solution for asynchronous programming. They allow you to write non-blocking code using launch, async, suspend, and delay. Coroutine scopes like global scope, view model scope, and lifecycle scope help manage their lifecycle. Interviewers may ask you to implement parallel tasks or explain coroutine usage. Kotlin collections like map, filter, and flatmap make data manipulation easy and expressive. These functions are frequently used in real-world Android apps for transforming and filtering data. Interviewers may ask you to solve problems using these collection functions. Modern Android apps use architecture patterns like MVVM, MVP, and MVC to separate concerns and make code maintainable. MVVM is the most popular, with model for data, view for UI, and view model for business logic. Understanding these patterns is crucial for interviews and real-world projects. The repository pattern abstracts data sources, making it easy to manage and test data logic. It sits between the view model and data sources like APIs or databases. Interviewers may ask you to implement or explain the benefits of the repository pattern in MVVM. Clean architecture divides your app into presentation, domain, and data layers. Use cases encapsulate specific business logic, keeping view models clean and focused. This structure makes your code modular, testable, and scalable. Interviewers may ask you to design or explain clean architecture. Dependency injection frameworks like Dagger and Hilt help manage dependencies and promote testable, maintainable code. They allow you to inject interfaces instead of concrete classes, following the dependency inversion principle. Interviewers may ask about DI frameworks and their benefits. SOLID is a set of 5 design principles for writing clean, scalable code: single responsibility, open-closed, list-of substitution, interface segregation, and dependency inversion. Applying these principles in Android development leads to robust and maintainable apps. Interviewers may ask you to explain or apply SOLID principles. Jetpack Compose is Android's modern UI toolkit, allowing you to build UIs using Kotlin code instead of XML. It's declarative, meaning you describe what the UI should look like, and Compose handles updates automatically. Interviewers may ask you to build or explain Compose UIs. Composable function is a special Kotlin function marked with @composable. It describes a part of the UI and can be combined with other composables to build complex layouts. Interviewers may ask you to write or explain composable functions. State in compose holds data that changes over time and triggers UI updates. State hoisting is the practice of moving state up to a parent composable, making it easier to manage and test. Interviewers may ask you to implement or explain state management in Compose. Modifiers in Jetpack Compose are used to decorate or modify composables, such as setting padding, background, or click behavior. Layouts like column, row, and scaffold help structure your UI. Interviewers may ask you to use or explain modifiers and layouts in Compose. Side effects in Compose are operations that affect things outside the UI, like showing a toast or logging events. Compose provides APIs to handle side effects safely during recomposition. Interviewers may ask you to explain or implement side effects in Compose. Unit testing is the practice of testing individual components or functions in isolation. In Android, JUnit is commonly used for unit tests, which run on the JVM and are fast. Interviewers may ask you to write or explain unit tests for your code. View models are easy to test because they don't depend on the Android framework. You can use JUnit and observe live data or stateflow to verify outputs. Interviewers may ask you to write tests for view model logic. Security is critical in Android development. You should never store sensitive data in plain text. Use encrypted shared preferences for small data and the Android key store for cryptographic keys. Interviewers may ask you about secure data storage and common security risks. ProGuard and R8 are tools for code minification and obfuscation. They make it harder for attackers to reverse engineer your app by removing unused code and renaming classes and methods. Interviewers may ask you to explain or configure ProGuard R8. Always use HTTPS to secure communication between your app and server. Implement certificate pinning to ensure your app only trusts your server. Avoid logging sensitive data and use secure authentication methods like OAuth2. Interviewers may ask about network security best practices. When the device rotates, the activity or fragment is destroyed and recreated. ViewModel helps retain UI-related data across these changes, ensuring a smooth user experience. Interviewers may ask you to handle configuration changes without losing data. Use Kotlin coroutines with a sync and await to run multiple API calls in parallel and update the UI when both complete. This approach is efficient and commonly asked in interviews. To support offline usage, use Room as a local cache. The repository checks connectivity and fetches from Room if offline, or from the API if online. Interviewers may ask you to design offline-first apps. CI/CD stands for Continuous Integration and Continuous Delivery Deployment. It automates building, testing, and delivering Android apps. Tools like GitHub Actions and Bitrise are commonly used. Interviewers may ask about your experience with CI/CD pipelines. Gradle is the build system for Android. It automates compiling code, packaging APKs, and managing dependencies. There are project-level and module-level build, Gradle files, each serving different purposes. Interviewers may ask you to explain or troubleshoot Gradle issues. Many developers have found this guide invaluable for interview preparation. Testimonials highlight its clarity, depth, and practical value for both beginners and experienced developers. Real success stories show how mastering these concepts can open doors to top IT companies. Anand Gaur is a seasoned tech lead with extensive experience in mobile app development, specializing in Android, Kotlin, and Kotlin multi-platform. He has mentored many developers and helped them crack interviews at top IT companies. His insights and guidance are reflected throughout this guide. Congratulations on reaching the end of this comprehensive guide. Remember, consistent practice and a solid understanding of these concepts are key to interview success. Stay curious, keep building, and approach each interview with confidence. You're now well equipped to crack your next Android interview.